Hello everyone, I am Narendra Gura, founder and CEO of Cybercode EduLabs. Today I'd like to demonstrate how we have successfully integrated a physical IoT device with our cybersecurity platform Digital Fort. This demonstration showcases how real-world IoT devices can be monitored, analyzed and secured through our platform in real time. Let's begin with the overall architecture. On the left, we have an ESP32 IoT device acting as a physical endpoint. The device continuously sends telemetry and security-related events through our secure communication layer to C3 Cloud, our private cloud platform. C3 Cloud authenticates the device, processes the incoming data, and securely forwards those events to Digital Fort. Our AI narrator then interprets these events, providing meaningful explanations and recommended actions to help security teams respond quickly. Finally, all actionable insights are presented to the security analyst through a single unified interface. Here is the ESP32 device used in this demonstration. Once the device is powered on and connected to the network, it begins transmitting telemetry to our platform. At the same time, it can also generate simulated security events to validate our detection pipeline. The ESP32 firmware is developed and uploaded using the Arduino IDE. The firmware is responsible for collecting device telemetry, generating security events, and securely communicating with our backend APIs. Here I am using the Arduino IDE to program the ESP32. The firmware is responsible for connecting the device to the Wi-Fi network and securely communicating with our backend. Once the device is powered on, it begins sending heartbeat messages and simulated security events to Digital Fort. As you can see, the ESP32 dev module is selected and the firmware has already been uploaded to the device. On the backend side, this Python application simulates different IoT security scenarios. Instead of waiting for real attacks, it generates controlled security events such as IoT Port Scan, Authentication Failure, Brute Force Attempt, Firmware Tampering, Data Exfiltration. These events are sent to our backend exactly like events from a real IoT deployment. Each event contains information such as the device ID, event type, severity, timestamp, and source information. I'll now execute the simulator. As you can see, the simulator has started sending security events continuously on Digital Fort Live Monitor. Immediately we can see the ESP32 device connected to the platform. The platform is now receiving security events in real time. Here we can observe different types of events including IoT Port Scan, IoT Authentication Failure, IoT Brute Force, IoT Firmware Tampering, IoT Data Exfiltration. For every event, Digital Fort classifies the severity, records the timestamp, identifies the source and recommends the appropriate response. Our AI narrator further explains the event in simple language. Instead of showing only raw logs, it provides context, explains why the event matters, and recommends the next steps for investigation. This demonstration validates our ability to integrate physical IoT devices with Digital Fort. Today we've shown an ESP32, but the same architecture can be extended to other IoT devices, industrial equipment, edge systems, and enterprise environments. Our vision is to build a unified cybersecurity platform capable of monitoring cloud infrastructure, servers, containers, and IoT devices through a single intelligent dashboard. Thank you for watching.